So what is OONI data? As you may have gathered from the previous lessons, OONI data is OONI probe test results. To understand each OONI probe test result, it is necessary to understand how each OONI probe test works. We'll discuss how OONI probe tests work in the following lessons. But for now, let's discuss some basics when looking at OONI data. An OONI probe test result can have three possible outcomes. It can be normal, confirmed blocked, or anomalous. An OONI measurement is annotated as normal if everything works as expected, based on OONI methodologies, of course. For example, if a tested website is found to be accessible, it is annotated as normal. If the testing of WhatsApp shows that it's possible to connect to WhatsApp from a tested network, that measurement is annotated as normal. Essentially, normal measurements are those where we do not find any signs of censorship, at least not based on OONI testing methodologies. In the OONI Probe apps and on OONI Explorer, which we'll discuss in the next chapter, you will see that normal measurements are annotated with a tick and a green header. When you test websites with OONI Probe, it is possible that the outcome can be confirmed blocked. These are cases when we are able to automatically confirm the blocking of websites. Currently, you will only find confirmed blocked measurements through OONI Explorer, which we will discuss in the next chapter, since the automatic confirmation of blocking requires backend analysis. Confirmed blocked measurements are annotated with an X and a red header. Based on our current heuristics, we are able to automatically confirm the blocking of a website if a censor serves a block page or if the DNS resolution returns an IP address that is known to be associated with censorship. A block page is a web page that is displayed when a user attempts to access a website they are not permitted to view. This is a censorship technique adopted by ISPs in many countries, such as Iran, Indonesia, Greece, Italy, and many others. When a block page is served by an ISP, the user does not view the content of the website they're trying to access. Instead, they view a web page, the block page, that informs them that they're not allowed to access the intended website. Here you can see an example of a block page served by ISPs in Indonesia. This is a transparent form of internet censorship, since the user is clearly informed that access to a website is intentionally blocked. Often, block pages even reference the law behind the censorship. There is therefore no ambiguity as to whether or not such a website is blocked or not. Since these cases of censorship are already confirmed, it's mainly a question of automatically detecting them. We are able to automate the process because block pages have fingerprints, which we add to the OONI database. This enables us to automatically confirm all cases of website blocking where those block pages are served. However, many forms of internet censorship don't involve block pages. Instead, ISPs implement internet censorship using a variety of different techniques, such as DNS tampering and IP blocking, as discussed in previous lessons. These other forms of censorship, which we are currently unable to confirm automatically, are annotated as anomalies. An anomalous OONI measurement provides a signal of potential censorship. An OONI measurement is annotated as anomalous when the tested service didn't meet all the criteria for accessibility based on OONI methods, and might therefore be blocked on the tested network. Anomalous OONI measurements are annotated with an exclamation mark and an orange header. Such measurements often do contain evidence of blocking, and most of your OONI analysis will involve looking at anomalous measurements. However, it's important to remember that anomalous measurements may contain false positives, which is why we're hesitant to annotate them as confirmed blocked. Within the OONI context, false positives are cases when a tested service may look like it's blocked, but it's actually not. And there are many reasons why false positives can occur. False positives commonly occur due to transient network failures. If OONI probe tests are performed on an unstable network, the test results may show signs of potential TCP/IP interference, when in fact, network errors can cause the TCP connection to drop. If a website is hosted on an unreliable server, the tested website may return failures, even though it's not blocked, resulting in false positives. If the DNS resolver of an OONI probe user, such as Google or their local ISP, provides an IP address that is closest to the user geographically, that IP address may differ from the IP address resolved from a control vantage point, potentially incorrectly indicating the presence of DNS tampering. Moreover, many websites serve different content depending on the country that the user is connecting from. In these cases, the HTTP responses from the network of the OONI probe user and from the control vantage point will differ, potentially incorrectly indicating the presence of HTTP-based interference. In short, there are many reasons why false positives can occur, which is why it's important to inspect the raw data in an anomalous measurement. How to identify false positives? Well, for starters, it's important to understand which OONI probe test that measurement pertains to and how that test works. Are you looking at a WhatsApp measurement? In that case, it's worth learning how the OONI probe WhatsApp test works, what it's expected to do, and what possible outcomes the test can have. This will enable you to inspect the raw data of the relevant measurements. To rule out a false positive, the main question you can ask is, does the tested service fail in the same way every time that it is tested on a specific network in a specific country? For example, if you find an OONI measurement which shows that the testing of Twitter.com presented an anomaly in Nigeria on 18th of October 2021, it's worth asking the following questions. What type of anomaly did the testing of Twitter.com present? This is annotated at the start of every OONI measurement page, and it can be a TCP/IP anomaly, a DNS anomaly, or an HTTP anomaly. In this case, we see that the testing of Twitter.com in Nigeria presented a TCP/IP anomaly. On which network in Nigeria did the testing of Twitter.com present this anomaly? Remember, censorship can vary from network to network within a country. By looking at the measurement, we can see that Twitter.com was tested on MTN network when it presented this anomaly. MTN network is a Pan-African mobile and telecommunications operator. Does the testing of Twitter.com on the MTN network in Nigeria present an anomaly every time it was tested around 18th of October 2021? Or did it only present an anomaly once, while all other measurements show that Twitter.com was accessible on this network? If the testing of Twitter.com only presented a few anomalies, then it's possible that those anomalies are false positives. But if the testing of Twitter.com on MTN in Nigeria presented anomalies most times it was tested in October 2021, then it's more likely the case that Twitter was in fact blocked in Nigeria. Do all anomalous measurements present a TCP/IP anomaly on MTN? If MTN did in fact block Twitter, then they most likely use the same technique. If all measurements show TCP/IP anomalies, it's likely the case that MTN blocked Twitter by means of IP blocking. If, however, we see many different types of anomalies that are not consistent, then we have a weaker signal of potential blocking. All these questions are necessary for checking whether the type of anomaly is persistent for a tested service. There are also the type of questions worth asking when examining OONI data in aggregate. To evaluate whether Twitter was blocked in Nigeria, it's useful to be able to look at many relevant measurements at once in order to be able to see whether most measurements presented anomalies and whether those measurements presented the same types of anomalies. We'll be discussing how to look at OONI data in aggregate a bit further during the next lessons. Finally, when looking at anomalous measurements, it's also worth evaluating other possible reasons that may have triggered the anomaly. For example, if the testing of Facebook presents an anomaly, it may be worth checking whether Facebook is down globally. If you are in a country like Iran or Cuba, you probably cannot access some services as a result of server-side blocking. This means that the website owner is blocking IP addresses from your country rather than your local ISP blocking your access to that website. But as mentioned, interpreting OONI data requires understanding how OONI probe tests work, and we'll be explaining precisely that in the next lessons.